Okay, so as we're writing these programs, we're going to need some mechanism to store information. And so for this, we're going to be using variables. So the first type that we're going to play around with is going to be an integer variable. So for this, what I encourage you to do is to copy down the comments as they come up, because this will be a really valuable thing that you can look back on, and it will also help you remember these things. So what we're going to do is we're going to put a variable here that will record the age of the programmer here. So you may choose to put a different age here, but I'm going to put in this first line of code. So int, which is short for integer. I'm going to break this down in just a minute. Now we're going to call this my age. And we're going to make it equal to, and you can put whatever age you are here. I'm going to put 40. And then we're going to be using this in some different calculations. So our program here now has the value of your age stored in an object called myAge. So we're going to break this down a little bit just to see what's happening here. So the first thing is this is supposed to be a comment. This is an integer variable. So an integer is a variable that can hold a number with no decimals. So we're going to see exactly how it handles these a little bit later, but you cannot store 40.5 into into an integer variable. It will not work. So breaking down this line of code, so int is the type. So all variables have a type, and this one is the type int for integer. Now the word myAge is the label. Now, pretty commonly, I'm going to be referring to this as the name of the variable in the videos, just because that's how I more casually speak about them. But anyway, technically, myAge is what's called the label of the variable. Now, we're going to be writing all of these in camel case. So that is where the first letter is always going to be a lowercase letter, and then every additional word in it is going to start with a capital letter. Your program will still function if you have a different method for this, but we're going to be writing ours in camel case. The last part is 40 is the value of the variable. So the value 40 gets stored into the variable. If you know what, I'll add this in, but we won't worry too much about what this means. Equal sign is the assignment operator. So the equal sign is the thing that says myAge will get this value, and we're going to be using those a lot more. So now, let's put a couple notes about variable labels. So labels. So there are a couple things that we are going to want to consider as we are writing the labels for this variable. And different programming languages handle this differently, but these are pretty common rules, so you should probably adhere to these no matter what programming language you're using, because they're pretty standard practice. So the first thing is they cannot start with a number. So something like 5 friends is not a valid term, but you could reverse it and friend 5 would be totally fine. I'm not going to leave this in. So it can't start with a number. Cannot have spaces. So this is why we're employing the camel case. So you can't have my space age as the variable name because it'll think that that's two separate labels. So they can't have spaces. Cannot have special characters. So you definitely can't put a backslash in your file or in your variable name anywhere. And there's a whole bunch that you can't use. And the other one is they shouldn't start with a capital letter. Labels with capital letters are usually reserved for something else that isn't a variable that we're not going to get to for a while. So it's a good idea to make your variables have a lowercase first letter. So these are kind of the rules. Okay, so now what can we do with a variable? So the first thing that we can do is we can output the variable. So cout my age. And we can put an end-l there. So if I run this program, it is going to output the number 40, and then it will skip to the next line. So if I run this, let's pull this up. Okay, so we get the number 40, and then that's it. Now, what we probably want to do here is extend this just a little bit. So we're going to put in my age is, and then we'll put my age. So let's see what shows up when I do this. So if I run this, so this line of code has text and a variable included, and it's going to mash them together in the output. Now watch what happened here. My age is 40. You can see there's no space here, so that's a bit of a problem. What we want to do is make sure that there's a space here. If you want it to show up, you have to specifically put it in. Some people will also put a colon in a space just to kind of like keep a separation. I kind of like that. So we'll keep going with that pattern. Now, let's do a little bit with some more variables here. What I want to do is I want to add 3 more that we'll be using as part of this program. So typically, your variables should go at the start of your program and not mixed in throughout your throughout the code, and that makes it easy to find them. Like if I need to change a value or see how did I spell that one, they are all going to be at the top, and that's why they're organized this way. So we'll put a few more, and I've put them above the output line. So next year, we'll have one for next year. And we'll have one for last year. And then we will put int. Now this will be a declaration. We're going to put 2 on the same line. So double age and half age. So this is how you declare 2 integers on the same line. So 2 ints. And a good rule of thumb is if you're doing this, they should probably have something in common. So something in common. You don't necessarily want to lump every single integer you have onto the same line because we might want to categorize it. So if you've got a program that has 200 variables, which can happen, you don't want to put them like all on one gigantic line of code. Okay. So what we want to do is we're going to put in next year. So next year, and what we're going to do is we are going to we're going to assign what the value of next year is. So this is going to be my age. So we're going to give it the value of my age, but we're going to add 1 to it. So the way we read this would be next year. Now this is important, gets the value. It's not equal sign. It's an equal sign, but that's not how we read it. My age plus 1. And you'll find, multiple instances where I'm going to say equals instead of gets the value. But we read this line as next year gets the value my age plus 1. So it takes my age plus 1, which would be 41, and then drops it into next year. Now, there's another way we can do this. Maybe we'll output this first. So cout next year, I will be next year. And we should get my age is, and then it will give us a next year. So my age is 40. Next year, I will be 41. Now what we'll do is we'll represent this in a different way. So C++ and other programming languages have a cute way to add one, because so often you're going to want to add one to a variable. So they've got this. Next year plus plus. This will add 1, and you might find it surprising that they have a whole separate way of adding 1, but it's just so common that they did this as a bit of a shortcut. So we'll do a cout the following year, I will be, and then we'll put next year again. So between these two lines of code, next year is going to get further updated by adding 1 to it, and then we'll get that to show up. So let's take a look. Next year I will be 41. The following year I will be 42. Okay, so let's do this now. What we're going to do is we're going to indicate last year. So I will do last year equals my age minus 1. So we'll do a cout last year I was, I'll keep consistent with my colon separators, last year. Okay. And just like the plus plus, we can also do a minus minus. So last year, minus minus, cout the year before I was, and then we'll put last year again. Okay, so we'll run this again just to test it out. Frequently run your program, because you're going to find as you start programming with C++, the most common thing is you're going to accidentally leave these semicolons off. So there we go. Last year I was 39. The year before I was 38. So we'll keep going. Now we'll just put the last 2 here. Double age is going to be equal to, now we can't do this, my age multiplied by 2, because this is the letter X. It acts as the letter X, like we might need it in a variable name or something. So X is not used for multiplication. The one we use is a star. So this is the symbol that we're going to use for multiplication. And then half age is going to be my age. Now, same thing, there's no divide sign on the keyboard, so we use a forward slash. So this will get double age and half age. So I'm going to put some outputs for this. Someone twice as old as me would be, and then we'll put our double age here. Cout someone half as old as me would be, and then we'll put half age. There we go. And let's take a look at our program. Okay, so someone twice as old as me would be 20. Someone half as old as me would be, twice as old 80, half as old, 20. Now, this is good for your output, but I want to show you, and you may actually run into this problem, and it's not really a problem, but what if instead of 40, I was 41? So what we're going to find is at the bottom here now, double age would be 82, but half my age would be 20.5. So let's see what happens here when I do this. I'm going to run it again. And we get our result. 82, so the double age worked totally fine, but the half age did not. It's still represented as 20. So what happens here is, especially we're going to see this a lot in divisions. So if it generates a decimal, it is not stored. Because think about that. If it rounded it off, 20.5 would round up to 21, which is not what happened. It just loses the decimal. It can't hang on to it. So this is a lot of different examples of using an integer, which is going to be a very, very useful variable type as we do some more complicated programming.